So we learned how to implement prototypal inheritance with constructor functions and then manually setting methods on the constructor function's prototype property. But now it's time to turn our attention to ES6 classes, which essentially allow us to do the exact same thing, but using a nicer and more modern syntax. Now, as I mentioned earlier, classes in JavaScript do not work like traditional classes in other languages like Java or C++. So instead, classes in JavaScript are just synthetic sugar over what we learned in the last few videos. So they still implement prototypal inheritance behind the scenes, but with a syntax that makes more sense to people coming from other programming languages. And so that was basically the goal of adding classes to JavaScript. But anyway, let's now implement person using a class. So we can write class and then the name of the class. And let's actually call it person CL. So that stands for class. And then curly braces like this. And so this is actually a class declaration. But just like in functions, we also have class expressions. And so that would work like this. So class expression and class declaration. And so then you can pick whichever you like the most. So it would be person CL and then class. And then just like a function, but without the arguments. Okay? And that is because, in fact, classes are just a special type of functions. Okay? So although we use the class keyword here, behind the scenes, classes are still functions. And therefore, we have class expressions and class declarations. Now, for some reason, I prefer the class declaration, and so I'm going to use that right here. And so this is how we write a simple class. And then inside the class, the first thing that we need to do is to add a constructor method. So just like this. And this constructor actually works in a pretty similar way as a constructor function. So as we studied previously, but this one is actually a method of this class. And in fact, it needs to be called constructor. So that is the rule. But just like in constructor functions, we pass in arguments basically for the properties that we want the object to have. So that's again first name and then the birth year. Now, the act of creating a new object actually also works in the exact same way as before. So using the new operator. And so therefore, whenever we create a new object, so like a new instance using the new operator, this constructor will automatically be called. So let's actually try that right away. And this time let's create Jessica here. So new person CL. And so as you see, everything here looks exactly the same as before. So it looks just like a regular function call. And again, we also use the new keyword here. And so therefore, just like before, the this keyword here inside of the constructor will also be set to the newly created empty object. And so just like before, we set the properties of the object like this. So this.firstName is equal to first name that we receive, and the same for the birth year. All right. So basically, when we create a new instance here, then it is this constructor that is going to be called, and it will return a new object, and then that will be stored here into Jessica. So let's just log this to the console. And so in fact, it looks just like before. All right. So here we basically have the properties that will be stored in the new object that we want to create. And so now it's time for the methods. And the methods we simply write like this. So we can simply add them here And all we have to do is to write their name. So just like a regular function in here. So this is very nice and very convenient. And so let's simply do the same as before. So this dot birth here. Now, what's important to understand here is that all of these methods that we write in the class, so outside of the constructor, will be on the prototype of the objects and not on the objects themselves. So this is really just like before, prototypal inheritance. And in fact, we're going to be able to confirm that here. So as we inspect this Jessica object, when we look into its prototype, then we will once again see the calc_h function here. All right. And so therefore, of course, we're going to be able to do this. And actually, we don't even need to log it to the console because the calc_h method already does that on its own. And so indeed, we get an h here. And so one more time, let me prove to you that Jessica underscore proto underscore underscore is equal to person CL dot prototype. And it is true. And so as you see, person CL here acts just like any other function constructor, with the only difference that this looks a little bit nicer. So with this syntax, we don't have to manually mess with the prototype property. All we have to do is to write the methods here, so inside the class, but outside of the constructor, and then they will automatically be added to the prototype property of the class, basically. So let me actually write that here. So they will be added to the prototype property of the person class, which once again is going to be the prototype of the objects created by that class. And we can take this demonstration even further by also adding a method manually to the prototype. So that's going to work just as fine. So let's create a greet method here. So let's just say, hey, this dot first name, and then we can call this on Jessica. So of course, Jessica dot greet. And so, as you see, that works just as well. All right. And so this is proof one more time that the class really just hides the true nature of prototypal inheritance in JavaScript. So of course, we could now do the same like this. And notice how there are no commas between the methods. Okay, so we could do this, take out this, and it would work the exact same way. You see? So this is great for people who are coming from another language and have experience with object-oriented programming, because it's going to be a bit easier for these developers to start writing object-oriented code in JavaScript. Now, if you're one of these developers, then please make sure that before just starting to use classes, you really truly understand function constructors and the prototype and the whole prototype chain logic. Now, to finish, I just need to say a couple more things about classes that are important to keep in mind. So first, classes are not hoisted. So first, let's scroll a bit here. Classes are not hoisted. And so even if they are class declarations. So function declarations, remember, are hoisted, which means we can use them before they are declared in the code. But with classes, that doesn't work. Second, just like functions, classes are also first-class citizens. First-class citizens. And so what that means is that we can pass them into functions and also return them from functions. And as I mentioned before, that is because classes are really just a special kind of function behind the scenes. And third, the body of a class is always executed in strict mode. Classes are executed in strict mode. And so even if we didn't activate it for our entire script, all the code that is in the class will be executed in strict mode. All right? So keep these points in mind if you want to work with classes. So now at the end of this video, you might ask if you should use constructor functions like we have been doing, or if instead it's better to just use classes. And the first remark I want to do here is that constructor functions are not like old or deprecated syntax. So it's 100% fine to keep using them. So one more time, this is more a question of personal preference. Now, if you're asking if you should use classes without understanding prototypal inheritance, well then the reply is definitely no. Now, some people actually say that classes are really bad in general and that no one should ever be using them simply because they hide the true nature of JavaScript. But I actually don't agree with that, and I think it's absolutely okay to use classes in your code as long as you understand everything that I just showed you previously about the prototype and prototypal inheritance. So you cannot just skip that part because you want to become an expert in JavaScript, right? And you also want to feel comfortable while writing your code, and that essentially means to understand exactly what your code does. So that's super important too. And so if you want to be confident, you need to understand. And so that's also the whole reason why all over the course I am going into such deep detail into how everything works in JavaScript. Now, what I personally like about classes is that they visually put all the code that belongs to a certain class, so like all the data here and all the behavior, all into one nice code block like this. With function constructors, in my opinion, it all looks just like a big mess. So like this. I mean, in this case, it's just a little bit of code, but this can get out of hand pretty quick. And in these situations, I think that this actually looks at least a lot better. But of course, that is just my personal opinion. What matters is that you start thinking about this yourself and take your own decisions based on what I'm explaining in these videos. Let's now talk about a feature that is actually common to all objects in JavaScript, and that's getters and setters. So every object in JavaScript can have setter and getter properties. And we call these special properties assessor properties, while the more normal properties are called data properties. So getters and setters are basically functions that get and set a value. So just as the name says, but on the outside, they still look like regular properties. And so let's first take a look at getters and setters in a simple object literal. And for that, I'm going to use the bank account example from the Bankist application. So, very simple object literal here. The owner is Jonas. Then some simple movements. So the values here don't really matter. Okay. Oh, and of course, I'm writing this object all wrong. Maybe you have already been noticing that. Okay, but now it should be correct. All right, but now to add a getter to this object, we can start by basically writing a normal method. So let's say that we want a method to get the latest movement. And so let's call it latest. And then to transform this into a getter, we simply prepend the keyword get. All right. And so let's simply return the last movement here. So that's this dot movements dot slice -1. But this is actually going to return an array, so an array with the last position. And so we can simply take that out using the pop method. And we could have used the structuring as well, but I didn't want to save this into an external variable first. And so now we can use this getter like this. So a count, and then we say latest, but we simply use it as a property. All right, so we don't call the method, but instead we write it as if it was just a property. So let's see, and indeed that returns 300. So this can be very useful when we want to read something as a property, but still need to do some calculations before. Okay, and now we can do the same also as a setter. So we say set latest again, and then here we can basically add a new movement to the array. And any setter method needs to have exactly one parameter. So in this case, that's simply a movement. So let's say this dot movements dot push, and then that movement that we just passed into. Now, it is not mandatory to specify a setter when we have a getter for the same property. Okay, so just the getter or just the setter would be enough. And so, how do we use the setter now? So if it was a regular method, then we would have to do this. So account.latest, and then call it with the movement, let's say 50. But now this is actually like a property and not a method. And so we can simply set it just like we set any other property. So we essentially set it equal to 50. And so now if we take a look at the movements here, it will then give us the complete array with the 50 there at the end. And so in a nutshell, this is how getters and setters work for any regular object in JavaScript. Now, however, classes do also have getters and setters, and they do indeed work in the exact same way. And so let's try them out now here in our person class. So here we can, for example, add a getter for the age property. So we can say get age, and then we return the age. So this is of course very similar to the calc age method that we already have here, but that doesn't matter because this is really just a demonstration example. All right, and so like this, we will be able to basically read the age of any object using a property. So let's try that here. For example, Jessica.age, and this time we actually need to log it to the console. And you see here, we now get the same value. All right, so you see that the getter is indeed just like any other regular method that we set on the prototype. And in fact, we can also check that out here. So if we take a look at the prototype of Jessica, it will be right there. Now it has these dots here because it's only calculated once we actually click this. Okay, so here too, it already looks as if it would be a property and not a method. We still have the get method down here, but then it's also kind of added as a property. All right. So that's a very simple use case of a getter, but setters and getters can actually be very useful for data validation. And as an example, let's try some validation with the name. So for that, I will actually change first name here to full name. And so now here we expect a full name. So a name which basically contains a space. So let's say Jessica Davis here. And so now we can create a setter for the full name property, which will check if this is actually a full name. All right. So set full name, and then we need the name itself, and then here we need some logic. So to test if it contains a space, if the name includes a space, and I'm not sure if it is called includes actually. Now let me just test it here very quick. Okay, we have to comment out this part. All right, so this method actually does exist. So I wasn't sure if it only exists on arrays, but indeed it also exists on strings. And so in this case, then we actually want to set this dot full name to the name that was received. But if not, we want to give an alert. So the given name is not a full name. So in this case, what's really important to understand is that we are creating a setter for a property name that does already exist. So full name is already a property that we are trying to set here, but then we also have the setter. And so now what's going to happen is that each time this code here is executed, so whenever we set the full name on the this keyword, then actually this method here, so this setter, is going to be executed. And so that name that we pass in as full name will then become this name. All right, let's check that out actually. And so now as we create Jessica here, you will see, and indeed we saw Jessica Davis here, but now we got this crazy error here of maximum call stack size exceeded. Now that's a very cryptic error message, but what happens here is that there is a conflict. So right now both the setter function and this constructor function are trying to set the exact same property name. And so that gives origin to this weird error. So what we need to do instead is to here create a new property name. And the convention for doing that, so when we have a setter which is trying to set a property that does already exist, then here as a convention we add an underscore. So again, this is just a convention, it's not a JavaScript feature. So it's really just a different variable name to avoid that naming conflict. However, now when we do this, we are actually creating a new variable. So a full name variable. So let's try this now actually. So if we try to look at Jessica Davis, you see that right now the property that exists is underscore full name. And so right now we cannot do Jessica.fullName because that simply doesn't exist. And so to fix this, we now also need to create a getter for the full name property. And so that will simply return the underscore full name. So let's see. So return this dot full name. And so if we try to do the same now, then you see that we are back to having this full name here. All right. And of course, the actual property that is here is now still underscore full name because, well, that's what we do here in the setter, right? But then we can also compute this full name just as we can compute DH. So this pattern here is important to understand whenever we try to set a property that already exists. Now let's try another name here, just to see what happens. And actually, after all this, so let's create a Walter object here, new person CL, that's right. And now we're just using a name with one word, let's say 1965. And so now we get this error. So Walter is not a full name. And so right now, if we check out Walter, it probably doesn't have any name. And yeah, it doesn't. So just the birth year now. But if we then put it as a full name, so Walter White, then indeed Walter like this, then we get the underscore full name. But just like before, we can then also access walter.fullname because of that setter, or actually of that getter that we just defined earlier. Okay, great. So this is another nice feature of classes that can be very useful sometimes. Now, we don't need to use getters or setters, and many people actually don't, but yeah, as I just said, sometimes it's nice to be able to use these features, and especially when we need like a validation like this by the time we are creating a new object. So that's essentially what this setter here does. Next up, we're going to take a look at yet another feature of classes, which is static methods. So let's check that out right now. In this short video, let's quickly gonna talk about static methods. Now, a good example to understand what a static method actually is the built-in array.from method. And let's just do that here in the console. So remember that we have the array.from method, which converts any array-like structure to a real array. So for example, document dot query selector. All right. So that's an error right there. And so you see, this now returns an array to us. And for some reason it is empty. Oh, and that's because query selector doesn't return a node list. So let's try query selector all. And so now indeed we get an array here. But that's not really the point. What's the point is that this from method here is really a method that is attached to the array constructor. So we could not use the from method on an array. So this is not going to work. All right. So from is not a function. And so that is because this from method here is really attached to the entire constructor, so the array constructor, and not to the prototype property of the constructor. All right? And so therefore, all the arrays do not inherit this method. Again, because it's not on their prototype. It's simply attached to the constructor itself. So array.from here is basically just a simple function, but it's a function that's attached to the array constructor. And the reason for that is simply so that developers know that it is related to arrays. We also say that the from method is in the array namespace. And we actually used that term before for some methods in the number and in the internationalization namespace. Remember, for example, number.parse float. So that's the same thing. Okay, so this method is another static method, and it's static on the number constructor. So it's not available on numbers, but only on this very constructor. All right, so these are some good examples that we understand what a static method is, and we usually use these kind of as helpers that should be related to a certain constructor. And so maybe you can imagine that it should be pretty easy to implement static methods or selves. And let's do that for both our constructor function and also for the class. So here I already have the constructor function that we wrote right in the beginning of the section. So this person here. And so to add a static method, all we have to do is write person. And let's say I want to create a very simple hey function. Okay, so which simply like waves when we call it. So let's just say console.log hey there, and then maybe some emoji so we can actually see it a bit better in the console. And so now, in order to call this, it is pretty easy. We just have to do person.hey, and that's it. So somewhere up here, we now should get this hey there. Great. But of course, this one is not inherited. So just like we cannot call the from method on an array, we cannot say Jonas.hey, because it simply is not in the prototype of the Jonas object. So there's no way that the Jonas object could inherit it. All right. Now, let's just take a look at the this keyword here. But this again should be pretty obvious. And so that's essentially the entire constructor function here. And the reason for that is because that is exactly the object that is calling the method. And so, as always, that is basically the rule. So whatever object is calling the method will be the this keyword inside of that function. And so here, that this keyword is simply that entire constructor function. Great. And now let's quickly take this and do the same in the class, where it is even easier. So here, to create a static method, all we need to do is to add the static keyword. So static hey, and then that's it. So let's just write that here. So that is a static method, while these ones is what we call instance method. So as it says here, these are methods that will be added to the prototype property so that all instances can have access to them. And therefore the name instance methods. Okay? And so now we can simply, let's do it here at the end. We can simply do person.cl dot hey. And so again, we get hey there. And this time the this keyword points to the entire class. All right. So keep in mind that these static methods are not available on the instances, and sometimes they are still useful to implement some kind of helper function about a class or about a constructor function. So we learned about constructor functions and ES6 classes, but there is actually a third way of implementing prototypal inheritance, or delegation, as we can also call it. And that third way is to use a function called object.create, which works in a pretty different way than constructor functions and classes work. Now, with object.create, there is still the idea of prototypal inheritance. However, there are no prototype properties involved, and also no constructor functions and no new operator. So instead, we can use object.create to essentially manually set the prototype of an object to any other object that we want. Okay, so if we can set the prototype to any object, let's actually create an object that we want to be the prototype of all the person objects. So essentially, let's recreate the person class from earlier. So let's say person, and then I'm calling it person proto, which stands for prototype, because again, this object is going to be literally the prototype of all the person objects. Okay? And now this is actually just a simple object literal. And so now what should we actually put in here? Well, we're going to put exactly what we put before into the prototype property. And so that was the calc_h method, right? So we did that actually here first manually. So we added calc_h to the prototype property of person. And then here we also did that, but in a more implicit way. So JavaScript did that for us behind the scenes. But now let's take this function here, or actually we can take all of this, because we can also write methods in this way in object literals. And so that's actually it. that's all the methods that we want the person objects to inherit. And so we put them in the prototype. And now all we need to do is to actually create a person object with this object here as the prototype. And for that, we can use object.create. So let's create a person called Steven here. And so now object.create. And here we pass in the object that we want to be the prototype of the new object. So that's person proto. And so this will now return a brand new object that is linked to the prototype that we passed in here. So Steven here is right now an empty object, and it will be linked to this person proto object, which will be its prototype. And we can actually already see that here in the console. So as I said, for now it is empty, but we already have the prototype, and in there we see we have calc age. All right. But now we don't have any properties on the object yet. So let's quickly fix that. So Steven.name. So I'm doing it here just like I would do in any other object literal. And so this is not ideal, of course, but we're going to fix that in a minute, because of course we want actually a programmatic way of creating new objects instead of having to do it like this. But again, for now, we are just worried about the prototypes and the prototype chain here. So we should now be able to say Steven.calcAge. And yeah, that worked. And so you see that we, just like before, implemented prototypal inheritance, but in a completely different way. And now, just to make sure that we're all on the same page here, let's make sure that we really understand this big difference. And so let's take a look at a diagram of what's really going on here. So here at the right side, we have the way it works with the constructor functions, just as we have been doing it up until this point. So when we use the new operator in constructor functions or classes, it automatically sets the prototype of the instances to the constructor's prototype property, right? So this happens automatically, and so that's nothing new at this point for you. Now, on the other hand, with object.create, we can set the prototype of objects manually to any object that we want. And in this case, we manually set the prototype of the Steven object to the person proto object. And that's it. Now the two objects are effectively linked through the proto property, just like before. So now looking up properties or methods in a prototype chain works just like it worked in function constructors or classes. And so the prototype chain, in fact, looks exactly the same here. The big difference is that we didn't need any constructor function and also no prototype property at all to achieve the exact same thing. So this is actually a bit more straightforward and a bit more natural, and I guess that it might also be easier to understand. However, the reason why I'm showing you this object.create technique right at the end is because in practice, in the real world, this is actually the least used way of implementing prototypal inheritance. However, it's still very important to know exactly how object.create works, because you will still stumble upon this in the real world. And even more importantly, we will need object.create to link prototypes in a next lecture in order to implement inheritance between classes. So with that, we're going to take object-oriented programming to a whole new level, and the object.create function is going to be crucial in that, as we will see. And of course, we can now verify everything I just said using code here. So we can do Steven.__proto, and so that is now exactly the object that we specified up here. So you see, this is exactly person proto. And that makes sense, right? Because here we said explicitly that person.proto should in fact be the prototype of Stephen, right? And so therefore, this of course is gonna be true, right? And it is. So now that we know exactly what's going on here, let's quickly create another person. So const Sarah equals object.create. And once again, here we use person proto. But now in order to set properties on this object, let's do it in a better way than what we did here. So doing this is a little bit weird, and it goes against the spirit of creating objects programmatically. So if we're serious about using object.create, we should implement a function that basically does this work for us. So let's create a new method here, and this can have any name. So I will call it init, but this is going to be a little bit similar to the constructor that we have in classes. So this one will also get a name, or let's say first name, and a birth year. And then just like before, we will use the this property and set first name to first name, and then this.birth year, set it to birth year as well. And so you see that this looks a bit like the constructor function that we created earlier, right? However, this has actually nothing to do with any constructor function, because we are not using the new operator to call this, right? We will simply do Sarah.init, and then we will pass in the arguments. So let's say Sarah and 1979, for example. And so let's then use calc_age here as well. And so then that just works beautifully as well. So here the this keyword will of course also point to the Sarah object now, but it does so because we explicitly called init on Sarah. So again, this has nothing to do with the constructor functions that we saw earlier, and it's also completely different from the constructor method that we have in ES6 classes. This is just a manual way of basically initializing the object, and this here could be any name. And indeed, we could have a method like this in any other object literal. All right. So essentially, this is how object.create works. So the big takeaway is that object.create creates a new object, and the prototype of that object will be the object that we passed in. So that's what matters from this video, and that's very important to understand in the future when we will implement true class inheritance, because for that we are going to need object.create. Now it's time to practice everything that you just learned about ES6 classes. And so let's now do coding challenge number 2. And the goal of this one is to basically recreate challenge number 1, but this time using an ES6 class. Then besides that, I also want you to add a getter, which should be called speed_us, and this one should return the current speed in miles per hour. So remember that the original speed is in kilometers per hour, and people in the US are usually not used to that, and so we can create a special getter called speed_us. And to do the conversion from kilometers per hour to miles per hour, all you need to do is to divide by 1.6. Then you should also implement a setter with the same name of speed_us, so that people can basically set the speed also in miles per hour. But of course, that value should then be stored in the class as kilometers per hour. And so before storing the value, you need to multiply it by 1.6, so to convert it back to kilometers per hour. And then take this test data number 1 here and create a new car and experiment with all of the methods and getters and setters. So have some fun with this one, and I see you back here once you are ready. Okay, so hopefully you did that without any problems, and you don't even need my solution. But of course, as always, I will still show it to you. And what I'm going to do is to simply copy the code that we wrote earlier, and I will then convert it to a class, because that's actually not that hard. So here we just need to call it class, and let me call it CL again for class. Okay, so then the curly braces, so one in the beginning, one in the end. Then this function is actually called the constructor, and the rest is the same. Here we don't need these, and here we don't need the prototype. So that's the whole point of using classes. And then we don't need this function. And besides that, that's actually it. So that's the constructor function plus the methods that we added to its prototype property, simply converted to a class. All right, so that was pretty easy. Now let's talk about the speed US getter and setter. So first up, the getter, which is easier. So speed US, and this one does not need any input. And it will simply return this dot speed and then divide it by 1.6 as I instructed up there in the text. All right, and let's already test this now. And the test data here is Ford going at 120 kilometers per hour. So that's a new car CL with the make of Ford and the speed of 120. So let's accelerate here a little bit. But before we do that, let's actually also read the speed in US, because I actually know that 120 is 75 miles per hour. And so then I can know if this actually worked. And this one here simply returns the value. And so we need to log it to the console. All right. So indeed, this 75 here coming from line 270 is this speed US property. So again, we basically transformed a method here into a property so that we read like this by using a getter. Then we accelerate a little bit, so we increase to 130. And so that means that these methods, they keep working. And so our conversion to class works flawlessly. And now to finish, let's just implement the setter here as well. So set speed US. And then remember, we always need to take exactly one argument. So that's going to be the speed, of course. And so here we want to set the speed, but of course, in kilometers per hour. And so we take the speed and multiply it by 1.6. And so now if we do for.speed equals 50 miles per hour, then let's take a look at the Ford object. And here, of course, it needs to be US. All right. And so here we set the speed to 50, and then what we get here is 80. And so 80 is indeed 50 times 1.6. And so I think that's actually it. And yeah. So challenge number 2 completed. So over the last couple of lectures, we explored how prototypal inheritance works in JavaScript, and we did that using a couple of different techniques. So we used constructor functions, ES6 classes, and object.create. Now, all of these techniques basically allow objects to inherit methods from its prototype. So to delegate their behavior to their prototype, right? But now it's time to turn our attention to more real inheritance. So in the way that we learned in the very first lecture of this section. So what I'm talking about is real inheritance between classes, and not just prototypal inheritance between instances and a prototype property like we've been doing so far. And I'm using class terminology here because this simply makes it easier to understand what we're gonna do. But of course, you already know that real classes do not exist in JavaScript. But anyway, here is what we're gonna do. So we will create a new student class and make it inherit from the person class that we have been using so far. So person will be the parent class and student will be the child class. That's because student is basically a subtype of a person. So a student is also a person, right? But it is a more specific person. And so this is an ideal child class. Now this is really useful because with this inheritance setup, we can have specific methods for the student, but then the student can also use generic person methods like the calc_h method that we have been using. And that's basically the idea of inheritance that we're going to implement in this lecture. Now, just like before, we will start by implementing this using constructor functions. So in this lecture, we will inherit between classes using constructor functions. And this is going to be a bit of work, but it will allow you to understand exactly how we set up the prototype chain in order to allow inheritance between the prototype properties of two different constructor functions. Then in the next lecture, we're going to do the same thing using ES6 classes, which, as you would expect, is a lot easier. And finally, of course, we will go back to using object.create as well. All right, but enough talk. Let's put this into practice now. So here I already have the person function constructor that we have been working with in the beginning of this section, and also the calc_h method that we set up on the prototype property of person. So this is just a copy of what we already did. And so now let's continue by building a constructor function for the student. So const student. Now usually we want a child class to have the same functionality as the parent class, but with some additional functionality. And so usually we pass in the same arguments, but then also some additional ones. So that's going to be again first name and birth year. And then we will also pass in the course. And so now everything works the same here. So first name is going to be first name. This dot birth year is birth year. And finally, this dot course is going to be the course that gets into the function. So you see that in fact, this student class here has kind of the same data as the person. So it also has the first name and the birth year, but then it has an additional property, which is the course. So now let's actually create a new student. So I'm calling him Mike here. Born in 2020 and studying computer science. And just to make sure, let's log in to the console. And here indeed it is. Let's now quickly add a method as well. So we take the prototype property one more time, and then let's create a method called introduce. And so here we're simply gonna log like an introduction phrase to the console. So for the student to introduce himself. So my name is this.firstname and I study, and then the name of the course. So let's call that here Mike.introduce. And all right, so that works just fine. Great, so far so good. However, there is one thing that we can and should improve here in our student constructor function. So right now, this part of the code here is basically a simple copy of the person function constructor. So of this one that we want to be the parent class, right? And as you know, having duplicate code is never a good idea. First, because it violates the don't repeat yourself principle. But second, and even worse in this case, is that imagine that the implementation of person here changes in the future. Then that change will not be reflected in the student. So instead of having this duplicate code here, let's simply call the person function. So person, and then we pass in first name and the birth year as well. Now, do you think that this is going to work? Well, let's see, and then I'm going to explain you why this doesn't work. So the problem here is that we are now actually calling this person constructor function as a regular function call. So we are not using this new operator to call this person function constructor. And so therefore, this function call here is simply a regular function call. And remember that in a regular function call, the this keyword is set to undefined. And so therefore, that's why we get this error here, that it cannot set first name on undefined. So instead of simply calling the person function here, we need to manually set the this keyword as well. So do you remember how we can call a function and at the same time set the this keyword inside that function? Well, we can simply use the call method. So the call method will indeed call this function, but we will be able to specify the this keyword here as the first argument in this function. And so, in this case, we want the this keyword inside this function to simply be the this keyword inside this function here, right? Because, as you know, the this keyword is going to be in the beginning this empty object that is being created by the new operator. And so it is on that new object where we want to set the first name and the birth year property, right? So if we check this now, then it is back to working. And so this is a much better and more robust solution. Okay, so far, this is what we have built. So it's simply the student constructor function and its prototype property, and then the Mike object linked to its prototype. And that prototype is, of course, the constructor function's prototype property. Now this link between instance and prototype has been made automatically by creating the Mike object with the new operator. So all of this is what we had already learned. So this is nothing new at this point, right? Now a student is also a person. And so we want student and person to be connected like this. So we really want the student class to be the child class and inherit from the person class, which will then function as the parent class. So this way, all instances of student could also get access to methods from the person's prototype property, like the calc_h method, through the prototype chain. And that's the whole idea of inheritance. It's that child classes can share behavior from their parent classes. So looking at this diagram, basically what we want to do is to make person.prototype the prototype of student.prototype. Or in other words, we want to set the underscore proto property of student.prototype to person.prototype. And if this sounds confusing, then please just pause the video here for a minute and keep looking at this diagram for some more time. So that's why I created it. Okay. Now, anyway, we are gonna have to create this connection manually. And to do this, so to link these two prototype objects, we are gonna use object.create, because defining prototypes manually is exactly what object.create does. Great. So let's go do that. So let's do what I just showed you on the slide here in our code. And it's important that you do this at exactly this point of the code. Okay? And I will tell you later why that is. So anyway, student.prototype should be object.create person.prototype. And with this, the student.prototype object is now an object that inherits from person.prototype. Now we have to create this connection here before we add any more methods to the prototype object of student. And that's because object.create will return an empty object. And so at this point, student.prototype is empty. And so then onto that empty object, we can add methods like this one. But if we did it the other way around, so if this was after we created this method here, then object.create would basically override this method that we had already added to the prototype object of student. Now, you might be wondering why we even needed to use object.create. So why didn't we just do this? So student.prototype equals the person.prototype, right? This maybe would have seemed a little bit more logical to do. But in fact, this doesn't work at all. And let me actually show you why that is. So if we do student.prototype equal to person.prototype, then we will not end up with the prototype chain that we need. Instead, we would end up with this, which is a completely wrong prototype chain. And that's because here we're actually saying that the student's prototype property and the person's prototype property should be the exact same object. But in fact, that's just not what we want. What we do want is the person's prototype object to be the prototype of student.prototype. So we want to inherit from it, but it should not be the exact same object. And that's why we actually needed object.create. All right, so let's get rid of this bad code. And here let's just say linking prototypes. And so now with all of this in place, we should be able to do Mike.calcAge. And indeed, we get the age of 17. Beautiful. So this worked just fine. And so let's actually now go analyze what exactly happened here. And we already know that this worked because of the prototype chain, but let's see exactly how. So when we do Mike.calcAge, we are effectively doing a property or a method lookup. So that is JavaScript trying to find the requested property or method. Now in this case, as we know, the calcAge method is of course not directly on the Mike object. It's also not in Mike's prototype. That's where we defined the introduce method, but not calcAge, right? So just like before, whenever we try to access a method that's not on the object's prototype, then JavaScript will look up even further in the prototype chain and see if it can find the method, so in the parent prototype. And that's exactly what happens here. So JavaScript will finally find the calcAge in person.prototype, which is exactly where we defined it. And that's the whole reason why we set up the prototype chain like this, so that the Mike object can inherit whatever methods are in its parent class, basically. So in summary, we are now able to call a method that is on a person's prototype property on a student object, and it still works. So that's the power of inheritance. Great. And since we're already here, let's also quickly complete the prototype chain. So just like before, object.prototype will sit on top of the prototype chain. So of course, we could still call a method like the hasOwnProperty method on mic too. It doesn't matter how far away in the prototype chain a method is. And with this, we now have the full picture of how inheritance between classes works with function constructors. And of course, with ES6 classes, it works exactly the same internally. All that changes is the syntax. So when we do the same thing in the next video using ES6 classes, then keep in mind that it's going to work just like I described here. And so now, just to finish this video, let's quickly inspect all of this also in the console. Let's say Mike.__proto. And so this is, of course, going to be this object here, which contains the introduce method, right? So this is nothing new, but you see here right in the console that this itself has a prototype too. So let's try this here. And so see the next prototype. And so now this is indeed the prototype which contains the calcH function. And so in fact, that is exactly this object here, right? And maybe it's even easier to visualize in the console like this. So taking a look at Mike itself, and then Mike's prototype is a person here, which is actually not correct, and we will fix that in a second. So, I mean, the prototype chain, everything is correct, but here it should say student. So you see that right now it says person, but Mike is actually of the type student. Okay, but anyway, here you see the introduce method that we defined earlier. And then if we go even further into this, so not this one, but this one, then you see, of course, the calcH function, which is in the prototype of the prototype, basically, right? So what I said that we need to fix is this. So when we take a look at student.prototype.constructor, then remember that ideally this should point back to the student, right? But here it points back apparently to person. So actually we should use console.dir. And so you see that JavaScript now thinks that the constructor of student.prototype is person here. And the reason for that is that we set the prototype property of the student using object.create. And so this makes it so that the constructor of student.prototype is still person. So we need to fix this because sometimes it's important to rely on this constructor property. And so if we want to rely on that, it should indeed be correct. But that's easy to fix. We can just say student.prototype.constructor and set it to student. But let me just try out some more things here. So just to make sure everything works. So we can again use the instance of operator here. And so this, of course, is going to be true because student is, of course, the constructor function of Mike. But if we try the same now with person, then that indeed should be also true. And so, in fact, it is. And so again, it's because we linked the prototypes together. So if we didn't have this, then this should be false. So of course, Mike.calcH is not a function in this case, because the prototype chain is now not correctly set up to find this method. But let's quickly take this out. And so now indeed Mike is no longer an instance of person. And of course, Mike is also an instance of object because that is also in its prototype chain. All right, so here we just proved that the prototype chain is in fact set up the way that we intended it to be. All right, and that's the end of a very long and, I admit, complex lecture. But I hope that I could still consolidate your knowledge about prototypes and the prototype chain even further, because now you know how to even manipulate the prototype chain yourself manually. And actually, let's now go test if you did actually understand right in the next coding challenge.